Good morning. Let's begin. Once again, we're back in our original classroom. It feels a bit awkward to be here, right? It's been a while. The inflation assignment we'll be doing class on Tuesday. And we're going to continue talking about inflation today in the context of future worth and capital recovery. So last time we did present worth analysis with inflation, and so let's just review some of the things since it was a bit of a long weekend. Inflation-adjusted interest rate is the combination of the real interest rate and the inflation rate that is predominant in the environment. And so it's the interest rate that you should use if there is F inflation and you want to have a real increase in purchasing power of I. And last time I introduced this formula at the bottom, and there was a little bit of question of like, people could understand why the inflation-adjusted interest rate included I and F, but then there was some question about why is it I times F at the end there. So I thought I'd show you where that comes from. It's when we're keeping track of two things simultaneously, the effect of inflation, which is F, and the effect of the real interest rate I that we'd like to achieve. And so what you can see here is that this is a factor that converts to the present value of some future amount, and what we're doing is we're discounting that future amount to the present, and we're reducing it by the inflation rate and the real interest rate that we'd like to achieve. And so 1 plus F, 1 plus I. So you see that if you multiply those two together, what you're going to end up with is the formula at the bottom. Any questions so far? Okay. So if you are trying to earn interest during an inflationary environment, then what you have to keep in mind is that banks aren't going to ensure you get a real interest rate. They pay whatever market rate they pay, but it's sometimes lower than the actual inflation rate that is out there in the environment. So sometimes the inflation rate is so high that your purchasing power will decrease. Hopefully that's not often the case. Usually you have this first instance, that the market rate the bank is paying is more than F. Now, what the book describes the market rate, that's just another word for another phrase for this variable I sub F. They sometimes call that the market rate. And they're saying it includes the effects of inflation and the real interest rate. Now today, during our in-class exercise, we're going to tackle the problem, the second one, that sometimes the market rate that is being offered by a bank is actually lower than inflation, and so you end up having a negative real interest rate, and so that your purchasing power will decrease over time. And for that reason, the banks hardly ever will quote a real interest rate. They're going to just talk in terms of the market interest rate, because it's not in their interest to highlight the fact that you're losing money by depositing into the bank. It's just better if they just say, this is the rate we're paying. And the other point about it is that, of course, inflation is always changing. There may be multiple inflation rates during a year, and so it would be difficult for the bank to keep up with that changing data. The text makes a point that when you're solving problems, you can either make all of the money go to the present using the inflation rate, because remember that in the future, the money is going to be worth less than it is now, just because there's more money in supply. The government is always printing a little bit of additional money, and so that's ultimately what drives the higher prices in the future, is an increase in the money supply. And so when you're trying to calculate what is the amount that has to be collected over time to pay for a current investment, one way to do that is with something called constant value dollars. Now, constant value dollars is, sometimes you'll hear, there was a news article that I read just this morning that said that a Spanish galleon had been found. I think it was in the Atlantic Ocean. Does anyone know what a Spanish galleon is? It's a ship that's full of gold and silver and gems, and they're saying that the value of this ship is more than $1 billion. That's how much gold, and a private company founded along with the government of, I think, Ecuador. I'm not exactly, I should have looked at it more closely, but they were saying, they quoted the value of it back in the 1700s when the ship was lost, and then they also quoted the value of it nowadays. And so constant value dollars are when you are trying to relate the value of something in the future to the value of something in the present. And so you can discount all of the money to a certain time frame using the inflation rate F, and then you solve the rest of the problem using the real interest rate. Or you can leave the cash flows as inflated dollars. And this second point is what we've usually been doing when we do our calculations with the cash flow diagram, is we've been combining our interest rate and the inflation rate together, because we haven't been separately accounting for F, our inflation rate. We've just been saying there's the MAR, and hopefully the MAR includes the real interest rate that the company wants to make and the effects of inflation. And so this is a table that's in your text, and it explains some of the different types of inflationary problems that you can expect. And you'll get one of each kind of these inflationary problems in the inflation homework that's due next time in class, just to get you practice for each one of them. Let's just talk about them briefly. There's case one where it's the simplest of all. You're just trying to find out what is the numerical number of dollars that's going to be sometime in the future. And when you do that, you're using the market interest rate, I sub F. Now here in this third column, where they're giving an example, they're saying, what if you had a present value of $1,000 over 7 years, you're trying to find the future amount. The combined market interest rate is 10%, and that 10% accounts for inflation and the real interest rate, both of them together. And the inflation rate component of it by itself is 4%. And so when you're calculating the actual number of future dollars, this is illustrating that you'd use the I sub F, which is the market interest rate. And you can actually think of this table as kind of a problem-solving guide for the homework. If you reach a certain problem and you're not exactly sure whether you should use the inflation rate or whether you should use the market interest rate or so on, you can see whether the homework problem you're working on maybe corresponds to one of these kinds of cases, and then it tells you a guide of which interest rate to use and what your strategy should be. All right. Case two is a little bit more complicated because you're trying to find out what is the purchasing power of the dollars. And purchasing power takes into account how much it would be worth in today's terms. And so you're trying to find out, was there a real increase in the amount? Now, they're introducing this 5.77% in this bottom one here. And 5.77% is the real interest rate when you're subtracting out the effects of inflation. And so remember that the market interest rate is 10, inflation is 4, and so 5.77 represents how much your purchasing power is going to go up during the 7 years that you're earning the interest. And so if you want to know the future amount, then that is what you would compound into the future with, the real interest rate. And this is numerically equivalent. It's just saying that you could compound to the future at 10%, and then you divide by the effect of the inflation rate to bring it down to 5.77%. All right, case three would be if you wanted to know how much you have to have in the future to buy $1,000 worth of goods or services now. And you can see that they're only compounding into the future using the inflation rate. And so it's for the same purchasing power. You don't take into account a real increase in the amounts. It's just you're trying to find out how much costs go up during that period. And then finally, case four takes into account the market interest rate of 10%. And so that's the combined effect of the real interest and also the the inflation. Okay, does everyone have a copy of the in-class exercise? Including our many late arrivals? Everyone have it? Okay. What we're going to do today is take into account for part one when the inflation is larger than the market interest rate. And this phrase in part one where it's talking about the nation's highest yield, that's actually a direct quote from a bank in the United States that's bragging about how they pay the nation's highest yield of 1.25%. But it turns out that that yield gives you a negative interest rate. So let's start on part one. You can see it goes through steps A through D. And if you're not sure what kind of calculation to do, maybe refer to those 4 different cases that was on the last slide we were looking at. All right, so here's the description where the bank is offering us less than the inflation rate. The amount they actually pay is 1.25%. And so in part A, where you're supposed to find the accumulated amount, that's talking about what is the actual number of dollars that'll be in the account at the end of 8 years. And so you should use this I sub f, the market interest rate, to find the future number of dollars in the formula there. So if we switch over here to the solution, I think as I was walking around, everyone was getting it just fine. 121,493, all right? And so if we have that number of dollars in the account, the question is, what is it worth in today's terms? And so we have to discount using the inflation rate, because it's the inflation rate, F, that governs the relationship between the actual purchasing power in the future versus now. And so the unfortunate thing is, if you put in the money into the account, along with the idea that you're going to leave it there for 8 years, you put in 100,000, and instantly it's only worth 95,908. Now, it'll still say 100,000 in the account. You know, if you look at the bank balance, it'll seem like the balance is going up. But what makes it worth less than the original amount is just that the cost of goods is going up at a rate that's faster than the account balance is going up. And so, if you can, it's better to buy actual goods that you're going to need in the future. Can you think of anything that you could purchase now that would be usable 8 years in the future? It's hard to do sometimes. You can't easily buy 8 years worth of food. There's some things you can buy, like maybe you could buy wheat. You know, wheat is going to last for 8 years. They're still finding like ancient stores of wheat from 3,000 years ago that's still edible, right? But you couldn't buy eggs for 8 years in the future unless maybe they're pickled eggs or dried eggs or something. Milk, maybe you could get powdered milk, but even powdered milk expires over 8 years. So it's very difficult to get away from using money as a store of value. You could buy gold, right? But the price of gold varies a lot. Right now, gold is lower than it's been in a long time. Gold is less than $1,100 an ounce. Real estate, okay, because they're not making more property, right? Land is one of the few things that they're not making any more of. I mean, they're making a little when there's a volcano in the ocean, right? But then there's also soil erosion, so maybe it all evens out. Huh? You'll go to Mars? That would be great. From the movies I've seen, it's very hard to breathe there. Yeah. Okay. So it's unfortunate that it's hard to to make a positive return in an environment where the inflation is greater than the savings account rate. You have to go in search of yield, as they call it. So there's other sources of yield like preferred stocks that pay a certain dividend, like a guaranteed dividend, or bonds. You may have to move away from savings account and money markets and CDs in a case like that. So in Part C, you actually calculate the real effect of when inflation is greater than the market interest rate that's being paid. And so we calculate that the real interest rate is negative 1.7%. That's the effect of putting it into that account. Now, would the bank account is the bank ever going to advertise this? Like, think about their billboard. It's right next to Sheikh Zayed Road. You know, deposit your money here and make negative 1.7% interest. That wouldn't make a very good advertisement, a billboard. They're not going to send you a text about that, encouraging you to save your money at a negative interest rate. So that's why they don't focus on the real interest rate. They just tell you what they'll actually pay you and not how bad or how good it actually is. Okay, the last part, in Part D, we said, well, what if we wanted our real interest rate to be 1.25% and not just our, the market rate? And so we could calculate that easily enough, combining together the inflation and the real interest rate. We get it should be about 4.29%. So any questions about this Part 1? All right, so some of you, I think, have already started on Part 2, and that's good. For the rest of us, let's consider the case of our company is investing 550,000 dirhams in a new crane. And so to cover that, the capital recovery, remember, is the amount that you have to have as an ongoing recurring payment in order to pay off equipment that was purchased in year 0. So if we were going to draw a cash flow diagram for this, it would be a line down at year 0, and then 5 lines up representing inflows in years 1 through 5. We want to have a real return of 9%, and so that's I, and we know that inflation is 5.5%. So the first thing you're going to have to do is calculate I sub f and then use that I sub f in this formula. I didn't give you the table for whatever that interest rate happens to be. Maybe it's a refresher to get the chance to use some of these formulas again. So let's calculate what is the annual amount that's required to recover the investment. Okay, let's take a look at the solution and then we can finish early. I think some of you need to go to a midterm exam and maybe there's registration. Concrete? All right, the exams never finish, do they? All right, Part 2, capital recovery. How do you know which I to use? There's 3 different rates here. There's the inflation rate, the real return, and from these 2 you can calculate I sub f. Would you know that you needed to calculate I sub f if I hadn't told you as your first bullet point, calculate I sub f? If you wouldn't have known, then hopefully the practice you're going to get from the homework will help you to learn when you should use which value. Because in a quiz or in an exam, I probably wouldn't tell you the bullet steps of guiding you to which I value to use. You'd have to be able to interpret that, from the problem statement. And so here, the way that you should know which I value to use is when it's asking how much should your company receive each year to recover the investment. And so you want to recover enough money from your company that not only is inflation covered, but then on top of inflation, your company is also making a real return. And so you have to think that's going to be a lot more than the company would have to receive if it was only going for covering inflation, or if the return it was receiving was an inflation non-adjusted return. So that's kind of the hint in the problem statement language that you need to use I sub f. And so this factor here is the ratio between A to P. And so that's why in order to find A, I multiply P by that whole ratio there. And you'll notice that I did my typical thing of intermediate steps just because if you show all your work, then it's easier to double check so that you can avoid a mistake. Or if you do make a mistake and it stays on the paper, the more steps you show, the easier it is for whoever's grading the paper to find what you did wrong and then give you more partial credit than otherwise. If you just went from the formula to the final answer with no intermediate steps, then it's harder to award partial credit. So that's why I always encourage students to show as many steps as you actually can. Any questions from part 2? Let's leave it there for today. Remember that when we get together on Tuesday, you'll have homework 13 to submit. I'm still not sure if we're going to meet here or back in the computer lab. You'll just have to wait for the announcement on iLearn on that. But we'll be done with inflation and moving on to Chapter 15. So I will see you on Tuesday. Good luck on your midterms.